Really nice question here. We're interested in rotating this triangle, but focusing on the path that C takes, in fact, the length of the path. The path itself that C follows is in fact called a locus because a locus is a set of points that follows a certain rule. And essentially the rule here is that we're rotating the triangle around different points. And what is going to happen with C as it moves around? It's when we first rotate the triangle, the center of rotation is B, and C is always going to stay the same distance away from B. So in fact, that is going to give us a circle. I could, if I wanted to be really accurate, because if I try and do it by hand, it probably won't look as good. I could actually do this accurately with a compass. Now, you don't need to do this in the math challenge, but just to demonstrate it, and this is actually what the path at C is going to follow. It's going to do this. Okay, and then what happens is C becomes the center of rotation, which takes us up, moves the triangle around again, and then A becomes the center of rotation, and C is going to move around with A as the center of rotation. So I'm going to do another arc from here. And once we understand that we've created a circle, or part of a circle, we just need to work out this length. That didn't quite come out. There we go. All right, it didn't look perfect. When I drew it on paper, it didn't look as good as that, but as long as you recognize it's a circle, that's the main thing. So let's just think about this. This is an equilateral triangle, which means this is 60, this is 60. We in fact have 120 degrees of a circle. So we're trying to find the arc length of a circle with 120 degrees. One way you could do this was to recognize that that is a third of a circle. So it's going to be a third. For just this first red part, it's going to be a third of the circumference, which is pi times the diameter. Now we're told that the length is 1, so the diameter is going to be 2. And that's going to be the red length. We're going to get 2/3 times pi as our exact answer. The black length is going to be exactly the same. So another 2/3 times pi. Add these together, overall going to give us 4/3 lots of pi. It's just like it's just like when you do 2x plus 3x, you end up with 5x. We're basically doing 2/3 plus 2/3, 4/3, but you keep the pi in there as well. Because we've got 2/3 lots of pi, we're adding another 2/3 lots of pi. Overall, we end up with 4/3 lots of pi. When you have 4/3 lots of pi, just finally, you can instead write it as 4 pi over 3. It doesn't matter whether you do the division first, 4 divided by 3 times pi, or you do 4 times pi and then divide by 3. You get the same thing. So you're always allowed to just like basically move things up like this. If you had, if you had 7 over 6x, you could write it as 7x over 6. Okay, so our answer is A. Just one final point I want to make. You could use the formula for the arc length of a general circle. So let's say you had a sector with an angle x, what you can think about doing is having the angle and thinking how much of a fraction of a circle do I actually have? I've got x degrees, the whole amount is 360, so my fraction is x over 360. And then I'm going to times my circumference, which in this case is pi d or 2 pi r, by that. And that will give you the arc length in general. With things like 120, you can go straight there and recognize that it's a third. But if you didn't see that, then you could write 120 over 360. That's what I'm kind of trying to demonstrate with this idea over here. And then that would actually simplify down to 12 over 36. Divide by 12 would take us back to a third. So just an alternative. Really like this question. Well done.